In this video, we just want to do a quick recap of all the rules we've learned in Chapter 5, because boy have we learned a lot of them. So let's recap them. We learned the addition rule for disjoint events. In case you're interested, we learned that in Section 5.2. We learned in Section 5.2 as well the general addition rule, which is when they're not disjoint. Right? We also learned the complement in Section 5.2, the complement rule. In Section 5.3, we learned the multiplication rule for independent events, as well as the multiplication rule for n independent events, when you can just string them along and keep multiplying one after the other for all the independent events. And then we learned the conditional probability rule. I should have written probability. Well, conditional rule, I'll leave it that way, which we learned in Section 5.4. And the general multiplication rule. What if they're not independent? Then you have to multiply the event of the probability of the first event times the probability of the second event, given that the first event already happened. Now everything in here is in symbols, right? So capital P for probability, parentheses for of, and then the inside portion is what we're looking for, the event we're looking for. So we are going to suppose a whole bunch of things and use those symbols to figure it out. Now we have no context here, so we're just going to use the rules and figure out which ones apply and use them. Okay, so let's start off at the beginning. We know that the probability of event E, P of E, is 0.43. And the probability of event F, whatever the heck that is 0.27. And we're going to start off right here. The probability of E complement. E complement is, according to the complement rule, 1 minus the probability of E. It's rule number 3. Okay? So that would be 1 minus 0.43, which is 0.57 last time I looked. And let's make a note to ourselves. So we're use rule number 3, the complement rule. There we go. First one done. All right. That was the easiest one, of course, so let's get a little trickier. Suppose the probability of E or F is 0.55. It wants us to find the probability of E and F. Okay, well that's a little tricky here. So if you look at E or F is either 1 or it's number 2. Number 1 is if the events are disjoint, so there would be no E and F. So there's no way it's number 1 because there's no probability of E and F, and that's what we're trying to solve. So it must be the second one. We're looking for the probability of E and F. So we're going to take that formula and we're going to substitute into it. There, just like algebra class, we're going to treat each of these pieces like a number that we can, and then whatever part we don't know, we're going to use X, amazingly enough. So probability of E or F, I just copied and pasted the rule. Now I know that this part is 0.55 because the problem told me so. And then I know that that's equal to, and then I know that this is 0.43, and then the probability of F is 0.27, and the probability of E and F is the part I don't know, so I'm just going to put an X in instead. Okay, well these two numbers, I need to get them out of there, so let me add them up first. So this is 0.55 equals 0.7 minus X. Okay, so we subtract away 0.7 from both sides because we want to get X by itself. When you take 0.55 minus 0.7, you get negative 0.15, and then you have negative X over here. Well, that must mean that X equals 0.15 if you divide both sides by a negative. And so this is the probability of E and F. There you go. So it's a little bit of algebra solving. You have to actually put in X for the unknown and solve for it. Luckily, everything else is numbers that are given to you, so you don't have to find anything else. It's just that one value. All right, now suppose the probability of E and F is 0.21, right? So it's a different problem, so ignore everything we've learned. So A and B, they're out. Now we're going to use the probability of E and F equals 0.21. Find the probability of F given E. Okay, well that's the conditional rule. Oh, I should have said up here. One sec. There. Just we used rule number 2, the general addition rule on that last one. I should have mentioned that earlier. Okay, now for this one, we're going to use the rule number 3, or excuse me, rule number, 6, the conditional rule, this one. Now I know it's the conditional rule primarily because of one of the things they're asking, right? I mean, technically, we could have used number 7 as well. 6 or 7 would have worked. So it doesn't really matter which one we want. Now we know that we want to use, let's see here, the probability of F given E, that's what I'm looking for. So, I mean, you could call it X if you like, or you could just call it probability of F given E. I mean, it doesn't really make any difference. But I know that it's equal to, all right, now the probability of E and F was given to me at 0.21, and the probability of E was given at the start of the problem at 0.43. So when I take the two and I multiply them, or divide them, excuse me, I find that the probability of F given E is approximately 0.4884. Remember, you're never, never, never allowed to leave a decimal inside a fraction. In math, that is bad, bad news. So always divide out decimals inside a fraction like that. All right, that's that one. Now it's time for, there's that word, independent. All right, so it's going to be independent, huh? So if we assume they're independent, we want to find the probability of E and F. Well, let's go back, shall we? We're obviously using rule number 4 here, because that's the one for independent events. Well, if you remember anything about independent events, you remember that they're actually really easy to do, because all you have to do is multiply the probability of E times the probability of F, and both of those probabilities were given to us in the problem. So that means that the probability of E and F is equal to, well, approximately equal to, I should say, because we're rounding a little bit, 0.1161. Right, if you multiply those two numbers. Done. Well, that was easy. Not so bad at all. So far, I think the hardest one was actually that addition rule one for letter B, personally. All right, now, oh, there's that independent again. They're independent. Find the probability of E or F. All right. Well, it's the same rule, sort of, right? The probability of E or F is equal to the probability of E plus the probability of F minus the probability of E and F. But independent's not really involved in there yet, but it's coming. But they still want the probability of E or F. And I don't know anything about being disjoint. Well, as a matter of fact, I do. I know that if they're independent, then they're not disjoint. So, I know I'm using the general addition rule. All right. So, let me back up. You know you want probability of E or F, right? So with the probability of E or F, you know it's either number 1 or number 2. It's the disjoint one or the non-disjoint one. If you don't know about disjoint, which you don't in this case, although if you remember, you learned that independent means can't be disjoint, but let's say you don't remember that. Well, if you don't know, then stick with number 2, because it's the general one. If they are disjoint, then the E and F thing will just end up disappearing on you, right? So if you're not sure if it's disjoint or not, use number 2. And that's what we're going to do. Okay, so I wrote up that general addition rule so we can look at it. The probability of E or F is the probability of E plus the probability of F minus the probability of E and F. So I know I'm going to use this rule. I know that the probability of E is 0.43. I know the probability of F is 0.227. One of the issues I'm having is this. I wasn't given probability of E and F. Au contraire. But I was told that they're independent. And in letter D, we said if they're independent, E and F, then the probability of E and F is 0.1161. So I'm going to subtract away 0.1161. And I can do that because E and F are independent. See part D. Right? Since they're independent, I know the probability of E and F, or I can calculate it. So I'm going to add up 0.43 plus 0.27, take away 0.1161. I get about 0.5839. Now, what's really crafty is, what if I had given you letter E, but not given you letter D? If this one hadn't been there, you would have still been able to calculate this, but you would have had to find the 0.1161 on your own and substitute it in on your own. Crafty, huh? That would have made it a harder problem if I hadn't given you this part first, which is a total possibility, right? Now, what if they were mutually exclusive? Now, remember, mutually exclusive is another way of saying disjoint, right? Disjoint, mutually exclusive, they mean the same thing. When you have one, you cannot have the other. Now realize what that means. If you have one, you can't have the other. So what's the chances of both of them occurring? This isn't really a rule. This is more the definition of disjoint, if you will. Right? If there is disjoint, then the probability of E and F both occurring is 0, right? Because you can't have both. You either have one or you have the other, but you don't have both. That's the definition of disjoint. Oops, and that was letter F. Sorry. My letters got wonky on me here. I don't know what I did, but I'm sure I can back up the video and find it somewhere. All right, last one, I think. Yep, last one. So now, what if their event E and F are mutually exclusive, and now we want to find the probability of E or F? Okay, well, you're told they're disjoint, so you could use rule number 1, right? Right there, disjoint event. Or you could use rule number 2, because rule number 2 is going to work. It's just that you have to know that the probability of E and F is 0. So I'm actually going to use rule number 2, right? So use rule number 2, the general addition rule. I just want to show you the difference. It would be minus 0 right here. And the reason is because event E and F are disjoint, right? See part F. And that means that you have 0.7. Now realize you could have also used rule number 1. Rule number 1 would actually have been easier, but I just wanted to show you that even if you don't remember to use rule number 1, rule number 2 always works. Rule number 2 is actually the better addition rule. So let me type that up real quick. Okay, what I just said. For part G, rule number 1, the disjoint addition rule would have worked, right? You just wouldn't have had even the minus P probability of E and F even in there. And that would have worked great. The thing is that the general addition rule is more powerful. It always works for OR problems. So if you're in doubt, if you're not sure, like for example, this one right here, letter E, when you didn't know what independent had to do with anything, then you're better off using rule number 2. Right? All right, we are all done with that problem.